Hi, everybody. My name is Brian O'Shea. I am the director of the Institute for Cyber-Enabled Research, and I'm a professor in the Department of Computational Math, Science, and Engineering in Physics and Astronomy, and was NSCL and now is EFRIB, the Facility for Rare Isotope Beams. So what I'm here to do is tell you a little bit about the Institute for Cyber-Enabled Research. So the mission of ICER is to be MSU's central research computing facility. What we do is provide high-performance computing, we provide user support, and we provide consultation with staff who are experienced in scientific computing. And so I will go into a little bit of detail about what each of those things mean. So high-performance computing is, we have a very large supercomputer on campus that is purchased by the VPR's office, so actually by a combination of the Vice President for Research's office and by individual investigators for the benefit of the university community. And it's a very large supercomputer, 1.75 petaflops, which is pretty good for a university. And it has lots and lots of GPUs, which are very useful for machine learning, among other things. We also try to buy 1 or 2 units of any new piece of hardware that comes along, which researchers who are trying to develop new algorithms, who are trying to optimize algorithms for different kinds of computers, can find really, really helpful. Also, we try to deal with different users' needs in different ways, because some people just need a lot of compute capacity, sometimes people need a lot of memory, sometimes people need many, many CPU cores that all share the same data set. And so we try to purchase a heterogeneous set of computing nodes that can address all of the different user needs. And so one of the more popular things is to have compute nodes with multiple terabytes of memory, which people use for bioinformatics and network analysis and things like that. We also have a great deal of high-speed network storage, high-speed storage space, which are connected to the supercomputer so that you can store your data while you're analyzing it and read and write it at a very high rate of speed. And we install lots of software packages, many of which are open source, some of which are proprietary. We can install things for people. And then we also have a hardware buy-in program. And so what does that mean? Approximately every 2 years, MSU buys a new supercomputer. And we're actually just about to do that. So we're about to put out the call for proposals to vendors sometime in the next few weeks. And what that means with the buy-in program is when we go to purchase a new machine, the university puts in some amount of funding for that. And then we put out a call for researchers on campus who are interested in purchasing their own nodes. And when you purchase your own nodes, that means that you will have dedicated access to that computing resource. And all we charge you for when you buy in is the hardware. So we don't charge you for the network or the file system or electricity, cooling, maintenance, all of that stuff. ICER essentially eats the cost of that. And we take care of all of the maintenance and we take care of all of the support for that. And in return, when you are not using that node on the supercomputer to do your own research, all we ask is that other people can use it essentially when it would otherwise be sitting idle. And so we will be doing a new hardware buy-in very soon. A node, the sort of cheapest node, will cost somewhere around $10,000 or $12,000, and depending on how much memory you want, whether you want GPUs or not, the price can go up by approximately an order of magnitude. And so, and of course, people can buy multiple nodes. It is typical for faculty to purchase this with startup, or departments to purchase it out of overhead return for the benefit of their entire department, that sort of thing. Okay. We also do quite a bit of support for both PIs and for users. And for users, the supercomputer uses Linux, and it also uses what's called a batch system because it is a large shared resource with many people trying to compute at the same time. And so it's not the same as your laptop or this desktop. So there is a certain amount of training that usually takes place. And so we have workshops that we teach on the basics of working on the supercomputer. We often have more advanced training in a variety of things. So I had mentioned R and Python and MATLAB, so there's a little bit of overlap, I think, with what CSTAT does. But we also train on specific bioinformatics programs, and we take requests from users for how to, for different things that we should create workshops and training sessions on. I also write a lot of letters of support for grants. There's a huge wave of proposals due in the next few weeks. I infer by the number that I have been asked to write this week. But basically, one of the things that is useful for people when writing grant proposals to NSF, NIH, DOE, et cetera, is demonstrating that there is sufficient on-campus computing capacity for the things that people are trying to do. And that's very useful to be able to say, in your proposal, this is available, I have access to it, and then I will write a letter of support, depending on the exact funding agency, detailing what it is that ICER provides. And then detailing that there, for example, if you plan to purchase hardware, when that's going to happen and how much it costs approximately. Also on the ICER website, we have template facility statements, data management plans, budget justifications, things like that, that are targeted around the hardware buy-in, and the data management plan and facility statements and that sort of thing are just about the supercomputer and what we do with data or the facility itself. Also, ICER, along with the Department of Computational Math, Science, and Engineering, runs a summer REU program. So that's a research experience for undergraduates. That's called ACRES. It's the Advanced Computational Research Experience. And one of the really nice things about REUs is, we let people submit projects for the REU to get summer students. It's extremely competitive. We get really fantastic students, but it is competitive for the faculty as well. So people put projects in. And so if you are writing an NSF grant, specifically NSF, but also NIH and some other units, some other federal funding agencies, you can apply along with your grant for an REU supplement. And what that does is it gives you an extra $10,000 a year, approximately, which goes right into this REU. And what we do is we just add an extra project. We bring in extra students that are guaranteed to work with you. And that's the REU supplements from the National Science Foundation in particular are heavily underutilized. Of everybody that has applied for one that I'm aware of, I think it's pretty darn close to 100% success rate. And so you can do that along with your proposal when you submit it. Or if you get an NSF proposal funded, then you can add an REU supplement either, because it is only about $10,000 for a given year, which covers student stipend, room and board, travel to campus and back home when the REU is over, and that sort of thing. It's not that much money by the standards of the NSF, and so very, very high rate of return on that. And then the other thing that we do is publicity for the work that's done with ICER resources. And Adele Hahn, who's in the back, does a lot of interviewing people, taking pictures, making videos of what people have done, advertising it on all of our different social media accounts. We put it up on YouTube, we share it all over the place, and we often do that in partnership with your department and your college. And so that's a good way to get your work out there. We also do consultation, and so it works a little bit different than CSTAT. So ICER has a handful of research consultants, and these are people with PhDs who are experts in a variety of areas, and what they tend to do is more one-on-one assistance with challenging problems that you have. And so a lot of the time what they'll do is help with research groups that have needs in specific areas, bioinformatics or plasma physics or large-scale data analysis, that sort of thing. They will help you write proposals. They will help you do training with your group if you have very specific needs with regards to the supercomputer. They'll also help people optimize their workflows because, again, supercomputers are different than a laptop. And so it does sometimes take some getting used to, and they'll help people automate things, that sort of thing. They will also install software for you if you have something that's very specialized or just a real pain to install. And in addition, if your needs are too great for the MSU supercomputer to meet, then what they will do is help you transition to other resources. And so there's an NSF-funded program called Exceed, which is sort of order of magnitude larger supercomputers at a few different places around the country, and they'll help you figure out how to write a proposal for that, get a startup allocation so you can test your code, actually write the proposal, submit it, that sort of thing. Let's see. So when do you need ICER? not everyone needs ICER, but if you have some problem that is just too big to do on your computer in a reasonable time frame, we are probably the people you want to talk to first. And reasonable time frame, of course, is one of those things you have to decide for yourself. But good rules of thumb are, if your data set is way too big to fit in the memory of your computer, so every time you try to load the data set, your program crashes and or your computer crashes, that's a good place to go. If you're trying to do some sort of analysis that takes days and days and days, if you're trying to do something where you're making some sort of model or doing some sort of analysis where instead of doing it one after the other, you have to do thousands of these, and it might be more expeditious to do all of those thousands at the same time as opposed to doing them one after the other. Or you need some sort of large-scale file system to store huge amounts of data. You need to do huge amounts of computation, so big fluid dynamic simulations or something like that. Or you have need of a specific type of hardware. So for example, if you do some sort of data analysis that would benefit from GPUs or from huge amounts of memory, we would be the people that you would come to talk to about that. Okay. So again, please talk to me if you want. You need more computation than is available to you locally. If you think that you might need more resources, even if you're not quite sure how. So one of the things that we really like to do is talk to people who are thinking about bringing more computation into their research and helping them figure out if that's a good idea and if ICER is the right place to do that. And then also, if you're interested in purchasing HPC hardware for your group's use or for your department's use or something like that. So to get a hold of us, you can go to contact.icer.msu.edu, or you can directly email me. My name is Brian O'Shea, and my email is o'shea@msu.edu. And never mind, I'll just flip it. Also, I should speak into the microphone for the benefit of the people that are remote. Also, we have these handouts that have a pretty comprehensive listing of what resources are available on ICER. Some are up front here, some are in the back. Please feel free to grab one of these and take them home. And a PDF will be available on a website somewhere for all the people that are remote, I have been assured at least. So anyway, but this details pretty much all the things that I just said, and I think that's it for me. So again, my email address is o'shea@msu.edu, and then here are all the ways that you can get a hold of ICER and find out about what we're doing. So thank you very much.
Do we have any other questions for our speakers? That was so comprehensive that.
I am a research administrator in ComArt, so I have a little bit of a. I was interested in what you talked about with the REU. Is that so? The REU the Acres REU. That's
yes.
Separate from the NSF REU. That's another
I'm sorry,
program.
I was referring to it in two different ways. It is the NSF-funded Acres REU.
Okay.
Yeah.
Okay.
Like
so
three acronyms in one name. Sorry.
Okay. So that is that a separate process from the normal, what I would call a normal REU, or is it?
Yeah.
Okay.
So we have NSF funding for 10 students a year, and we usually sort of scrape together funding.
When
for
you
a few
say
more
we, you say
here.
You mean ICER.
ICER.
Okay.
Yes, that's correct. So, and then when if faculty want to do REU supplements, essentially what we do is put them in the same. We put all the money together, and we just turn it into a larger REU. And then those students, so we take care of all of the administration, and that's one of the nice advantages for potential PIs. You give us the cash, we take care of all of the recruiting.
Okay,
we take care of all of that. You get to choose the students that you would like us to make an offer to. They come, we take care of housing and all travel and all that stuff.
Okay, so if a faculty member in our college received an NSF award and also received an REU, we would contact ICER and say, hey, we have this REU, can we put it in the pool?
Yes.
And then,
Yes, though I would strongly encourage them to talk to me ahead of time.
Sure, okay.
Because that's actually one of the kinds of things where if you were submitting the REU supplement along with the proposal. So when you, because again,
Yeah.
you can submit REU supplements essentially as an add-on to a proposal that you're submitting, or you can do it afterwards.
Yeah,
right?
our faculty
And so
typically do it afterwards. So.
almost everybody does because
Yeah.
hardly anybody knows about this.
Right,
And so, and also I think people kind of suspect that maybe it'll hurt their chances of getting a grant.
Yeah,
but,
yeah.
But whatever. But it's better to talk to me before you put in
Okay.
the supplement so that we can make sure that whatever projects you have in mind actually make sense with the REU.
Okay.
And that sort of thing.
Perfect.
So
Thank
yeah,
you
but
very
I
much.
really encourage people to do that.
Awesome. Thank you very much.
Any other questions for Brian or Marianne? Yeah.
Is ICER in the business of securing and sequestering data for individual investigators?
Could you elaborate on what you mean?
Well, you'll see on NIH and NSF grants, they want assurances in the grant that the data is going to be stored and protected and safeguarded. And I think BRIC is involved in that, but I was wondering if ICER does that as well.
So there are different kinds of data security. So for example, ICER has good cybersecurity to essentially keep people from logging on to the supercomputer that should not have access to it. And we use the standard encryption and sort of network security tools that people use for those kinds of things in high-performance computing. We do have the capability to encrypt data. We often choose not to do that. The reason is that it actually impacts performance quite a bit if you're encrypting data, because you have to encrypt it, well, depending on what you're doing, you have to keep it encrypted while it's in memory and or on disk and or sort of in transit between places. Which typically, when we're moving data around from machine to machine, it's always encrypted. It is not on our supercomputer. So in other words, data at rest on the supercomputer, if you set your file permissions incorrectly, other people can see it. We are not in the business of maintaining essentially a FERPA or FISMA or all of the other type things, secure data. So we don't do ITAR, for example. We do support BRIC's computing resources who do some of those things. I cannot remember exactly which ones they're compliant with. And we have explored the idea of doing so in the future. It's just it's actually quite expensive not to do it, but to document it, to the satisfaction of NSF or DoD or whoever. But if there was someone who really wanted to do it, we would be happy to work with them.
Thank you.
And just as an addendum to that, there are people in IT services, particularly in analytics and data science, so ADS, who have done some work with that for cloud-based computing solutions. And they've worked out a lot of how to do that. So if you do have something like that, there are folks in IT services who might be able to help. And feel free to contact me and I can put you in touch.